Okay, today we're learning about parametrics. This is the last unit of the year, and then we will get into the final exam review. Alright, parametrics are methods of defining a curve using different parameters. An example is when we use time as a parameter to represent the position or the velocity or other pieces of information about something that's moving. A lot of times we use parametrics in things like physics. Alright, so your homework tonight, you're going to do the way that we do the lecture slides today. And I'm going to use this as the graph paper. Okay, example A, directions. We want to make a t-table. You've got to have a t-table for all of your problems on homework tonight. Graph by hand, eliminate the parameters. So we're looking here at eliminating the variable t and then identifying what type of graph we've got. So we've got these two equations. X is equal to 4t plus 5 and y is equal to 2t minus 1. So we have x and y both in terms of t, that parameter that we want to eventually eliminate here. And our domain is all values of t between 0 and 5, inclusive of both of those. So we want to make sure that we put those both on our graph. So the first thing I'll do is make a t-table. Now we have three variables here, so we need to make sure we represent all three of those in our t-table. And because x and y are both written in terms of t, we'll have t to the far left of our t-table. Now, the domain of t is 0 to 5, so I'm going to make sure in my t-table that I include all of those numbers, 0 through 5. Okay, and then we're just going to plug these in. So when t is 0, x is 5, and y is -1. And when t is 1, x is 9, y is 1. When t is 2, x is 13, y is 3. When t is 3, x is 17, and y is 5. And then we get 21, 7, 25, and 9. Alright, so before I get into the algebra of eliminating the parameter, let's just graph this. Now you want to make sure that you have good scales because we want to make sure that our graph is going to fill up as much of the space as possible. Now when I graph, we're just graphing x and y. We're not including the values of t. We use t to find the values of x and y. So our ordered pairs here are actually 5, -1, 9, 1, 13, 3, 17, 5, 21, 7, and 25, 9. Alright, so we're just going to plot those points. On the x-axis, we need to make sure that we hit 25, and on the y-axis, we need to make sure that we get to at least 9. So, looks like I'm going to count by 1, and then I'll go by 3 on the x. 3, 6, 9, 12, 15, 18, 21, 24, 27. Okay, on your graphs, you want to make sure that you are super clear about the scale. The scale is going to change a lot in this unit. Just make sure you're good on that. Okay, and then I'm just going to plot those points. So, do your best. Gauge 5, -1 would be down here. 9, 1 would be here. 13, 3. 17, and 5. 21 and 7, 25 and 9. Okay, and hopefully we can see it. Ultimately, what we're graphing in this case is a straight line. Oops, excuse me. Remember that our domain was between 0 and 5, so we are going to make sure that our graph stops when t was 0. And when t was 5. So we're not drawing arrows, we're not going outside of that domain. Okay, so let me identify. This is a line. Not too hard. Okay, so we've got the t-table, we've got the graph, we've got the identity, and the last thing I need to do is the algebra to eliminate the parameters. So I want to take these two equations using a system of equations, and I want to get rid of t. We want to eliminate t so that we have x in terms of y or y in terms of x. So I'm going to move this graph so I have some space. And there's a couple ways you can do this. You can use substitution. You can substitute this equation when you solve it for t into the second equation, or we can use elimination, which is what I'm going to do here. So I'm just going to multiply the second equation by -2, and then I'm going to bring it down here. X is equal to 4t plus 5. That doesn't change, but we get -2y is equal to -4t plus 2. Okay, now we see if I add these two things together, the 4t and the -4t cancel. I left with x minus 2y is equal to 7, and then we can solve for y. So I'm going to get y by itself. That's our equation. So let me move this up. Y is equal to 1/2 x minus 7/2. That is the equation that represents this line that we just graphed. Okay, example A done. Let's do one more on this video. Okay, next problem. Same thing. We want to make a t-table, graph by hand, eliminate the parameter, and then identify what the graph is. So we have these two equations, x is equal to 1/2 root t and y is equal to 2t minus 3. We have a different type of domain here. We have for t, all values of t greater than 0. So we will have an arrow on part of our graph here. So let's start with the t-table. Again, t, x, and y. Now, obviously, I'm not going to go from 0 to infinity, so I'm just going to plug in a few numbers. Now, you can choose to make your life easier or not. If you plug in like perfect squares for t, when you take the square root, it's kind of nice. It's totally up to you. Doesn't matter. I'm just going to go 0, 1, 2, 3, 4, and then plot those points. So when t is 0, x is 0, y is -3. When t is 1, x is 1/2, and y is -1. When t is 2, x is going to be root 2 over 2. It's about 0.707, and y is 1. When x is 3, we get root 3 over 2. It's about 0.8 something. And then y is 3. And then when x is 4, we get 1 for, when t is 4, we get 1 for x and 5 for y. Okay, so let's graph this, and then we'll identify the graph. So I'm going to use the same paper, just a different place. Now, we want to make sure we're plotting the points 0, -3, 1/2, -1, root 2 over 2, 1, root 3 over 2, 3, and 1, 5. So I want to make sure that I fit those values on my scale or on my graph. Now, these are less than 1, so I don't have to worry about going anywhere except for up to 1. On the x-axis, my biggest value here is 5 on the y, so we want to make sure we fit all of that. Okay, so I'm going to scale by 1 on the y, and then I think I'm going to go by 0.1 on the x. So 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, 0.8, 0.9, and then 1.0. Okay, and plot the points. 0, -3, right there. And then 1/2, -1. And then root 2 over 2 is 0.7 something. So 0.71, and we'll just go like a little bit more. Root 3 over 2 is 0.8 something, so 0.83. Then I'll go just a little bit more. And then 1/5. Okay, so we're just going to gauge the look of this graph here. remember that because the values of t are greater than or equal to 0, we will cap it here. We don't go any more to the left, but we will draw an arrow going up to infinity in the x direction, in the positive x direction. Okay, so maybe kind of hard to see, but this is a parabola. Now, if we had picked perfect squares of t to plug in and then graphed those, we might have been able to see the curve a little nicer, but that's another way to do it. Okay, last thing we need to do, we've graphed by hand, made a t-table, and identified. Let's eliminate the parameter using some algebra here. So again, different ways we can do it. I don't like this square root here, so what I'm going to do is I'm going to take the first equation and I'm going to solve for t, and then substitute it back into the second. So if I take this first equation and I try to get t by itself, the first thing we're going to do is multiply both sides by 2, and then I will square everything. So I get this, t is equal to 4x squared. Okay, so I'm going to take that value of t, and we're going to go into the second equation, and we're going to replace t with 4x squared. And we get this, y is equal to 8x squared minus 3. So we did it with algebra. We eliminated the parameter, got y in terms of x. If you had a hard time seeing this graph was a parabola, all you had to do was look at that equation, and you'd be able to see it there. Okay, second type of example problem. These are going to be homework problems 15, 17, 19, 23, and 25. Ooh, that is, give me 1 second, let me fix the focus. Okay, no t-tables here. You only need t-tables for numbers 7 through 13 odd. Okay, so don't do t-tables for these ones. You're welcome to, but you don't have to. Okay, eliminate the parameter, identify, and graph. So let's do the algebra first on these, and then we will do everything else. This keeps changing. There we go. Okay, so for example C, we've got two equations. X is equal to 5 cosine t, y is equal to 7 sine of t, and we want to get rid of t. We've got to get t out of the way. All right, so cosine, sine, super fun. This gets a little bit more complicated. Here is what we are going to do. I am going to get cosine and sine of t by themselves in each equation. So that is going to look like this. X over 5 is equal to the cosine of t. And then in the second equation, y over 7 is equal to the sine of t. And then I'm going to square each of these. Okay? Ultimately, we are using elimination. You can see where we're going with that. If not, don't worry about it. Okay, so what is that going to look like? Well, that is x squared over 5 squared is equal to cosine squared. And y squared over 7 squared is equal to sine squared. Now, this equation and this equation are equal to the ones we started with. We just manipulated them. So, if I combine them with addition, we're going to get x squared over 5 squared plus y squared over 7 squared is equal to the cosine squared of t plus the sine squared of t. Alright, don't forget those trig properties. They come back. We've got x squared over 5 squared plus y squared over 7 squared is equal to 1. That is the equation without the parameter. Now, this is an ellipse. Easier to identify like that, so let's graph it. So this is an ellipse with its center at 0, 0. Goes 5 units left and right and 7 up and down. So it is more tall than it is wide. And let's graph it. So I'm going to use the same paper. I'm going to move it up a little bit. Okay, example C. Graphing this equation. Okay, center 0, 0, I will probably scale by 2. So 2, 4, 6, 8, 10, 12, 14. And then I gotta go down. 2, 4, 6, good enough. All right, 5 right and left, 7 up and down. There's my ellipse. Okay. All right, now it's time for you guys to try one. So, have the sub or somebody pause this video, and I want you guys to work through this example. Okay, example D. Eliminate the parameter, identify, and graph. Negative 2x is equal to 4 plus t squared, y is equal to t minus 3. Do that now, have somebody pause the video, and then come back for the answer in just a minute. Okay. Answer looks like this. I solved for t in the second equation. Replace the value of t in the first equation with what we got, y plus 3. Make sure you FOIL correctly. Do some algebra. And you get this equation. X plus 2 is equal to negative 1/2 y plus 3 squared. You got a parabola that is going to be opening to the left because y is a squared term and it has a negative stretch. Its vertex here is negative 2, negative 3, and this is what the graph looks like. All right, last example we're going to do, and then you guys are going to work through your homework for tonight. Letter E, example E. We want to eliminate the parameter and identify. So in this case, we are not going to graph. I'm not going to graph this one. You will graph on your homework. All right, example E. We've got these two equations. X is equal to 4 square root e to the power of t plus 1, and y is equal to e to the 2t. There is a typo on my slide. This should be 2 times t. Please fix that. 2 times t. Let me rewrite this. Y is equal to e to the 2 times t. Okay. Here we go. I am going to solve for e to the t. Because I have e to the t here, and I have some form of e to the t here, I am going to use the first equation, get e to the t by itself, and then plug it in where we see it in the second equation. So I'm just going to subtract 1 from both sides. We get 4 root e to the t, and then divide everything by 4. And then we're going to square everything. So we get this. We get x minus 1 over 4 squared is equal to e to the t. All right, I'm not going to bother with simplifying that until the very end. Now I have e to the t by itself. I'm going to go back to this equation. Y is equal to e to the 2t. That's the same thing as us saying y is equal to e to the t squared. Remember the rules of exponents. If we have something being raised to a power to a power, we multiply those exponents. Okay, so let's replace the value of e to the t from the first equation into the second. Y is equal to x minus 1 over 4. That quantity squared, that whole thing is now being squared. All right, I get this. Y is equal to x minus 1 over 4 to the 4th power. I'm just going to leave it like that. Okay, now I had a typo here, but if we had kept this equation, y is equal to e to the 2 plus t, remember that if we add exponents like this, it would be the same thing as writing it like that, and e squared is just a constant. So that could have worked also. But anyways, that was a typo.